2018 paper, chemistry paper, and the code is D. The first question 61 number is that for 1 molar aqueous solution of the following compound, which one will show highest freezing point? And the options are here. This question is from chapter Solution and Colligative Property. Solution and colligative property. Solution and colligative properties. This is 12th class physical chapter, physical portion chapter. The chapter is in 12th class syllabus. So he is asking about the highest freezing point. So we have one formula, delta TF is proportional to molality into I, and this I is equal to want of factor. Want of factor. Now I can say the difference in freezing point means T0 minus Ts is proportional to molality into I. As he have said, he has told that 1 molar aqueous solution of following compound means for each solution molality is 1. That means T0 minus Ts must be proportional to I. Now this T0 is for pure solvent, while this Ts is for solution. He is asking ki which is having highest freezing point. So Ts will be highest if value of I is lowest. So we have to find that which is having lowest value of I. I means how many ions are produced by a molecule. So for this compound I is equal to 1. This compound will produce, we are assuming that these are the salt and they will dissociate 100%. So alpha is 1 for all these compounds. This molecule will dissociate into 4 ions, means I is equal to 4. This dissociate into 3 ions, means I is equal to 3. This dissociate into 2 ions, means I is equal to 2. So the lowest value of I is for first option. So answer is first option, having highest value of Ts means lowest value of I. Question 62 is hydrogen peroxide oxidizes FeCN6 minus 4 into FeCN6 minus 3 in acidic medium, but reduces FeCN6 minus 3 to FeCN6 minus 4. The product formed are. So in the first part, H2O2 is oxidizing FeCN whole 6 minus 4 into FeCN whole 6 minus 3. Now if we see, it is acting, if it is oxidizing from plus 2 to plus 3 state, that means it is oxidizing agent, and oxidizing agent is reduce itself. So the oxidation state is minus 1. So the other product is H2O, where oxidation state of oxygen is minus 2. So when H2O2 is reduced, it will act as an oxidizing agent, and since it is reduced, so oxidation number will further decrease. So it will produce H2O in the first option. In the second option, H2O2 is reducing FeCN whole 6 minus 3 into FeCN whole 6 minus 4. Now in this question, it reducing means it is working as a reducing agent. Plus 3 to plus 2 state, it is converted iron. So when H2O2 is acting as a reducing agent, its oxidation will take place. When H2O2 is oxidized, it will produce O2, and in O2 oxidation state is 0. So here oxidation number is increasing, here oxidation number is decreasing. So the option is, correct option is 4. In the first option it is giving H2O, and in the second option it is giving H2O plus O2. In the first option it is acting as an oxidizing agent, in the second part it is acting as a reducing agent. Question 65. An alkali is titrated against an acid with methyl orange as an indicator. Which option are correct? Is correct? Base, acid and endpoint. So when we are looking for methyl orange, this indicator has pH range of 3.1 to 4.4. It means it will change color between this range. That means it requires acidic medium for color change. But it requires, for the sudden color change, the medium should be strong acidic. So acid should be strong, and there are 4 options which is having acid as a strong. Now the color of methyl orange is from red to, or we can say yellow to red. Red color is shown in acidic medium, while yellow color is in basic medium. Now what question is saying? That alkali is titrated. Alkali means base. It is titrated against acid, means HA. If we take BOH in a beaker and we are titrated against acid HA, drop by drop it is falling into this solution. So if we add a methyl orange indicator in this solution, the methyl orange in basic medium, it is yellow in the color. So first it is yellow, and after neutralization point, when we add further HA, so medium becomes acidic and it changes from yellow to red color. So the option is, 4th option is correct, which is having the acid must be strong, and if we are taking base as a weak, there is no problem. Base could be the weak or either strong. So the end point is from yellow to red. This color is for phenolphthalein, this color is for phenolphthalein. So there are chances that out of these 2 options, one is correct. But since he has said that the alkali is titrated, means in the beaker we are putting base plus methyl orange indicator, and in the basic solution methyl orange is yellow in color. So gradually we are putting HA and it changes color from yellow to red. C2, it was from redox oxidation number, and question number 65 was from titration part of ionic equilibrium. Now we are discussing question number 68. This question 68 is from chemical equilibrium. So in this question he is asking which of the following lines correctly show the temperature dependence of equilibrium constant K for an exothermic reaction. So it is given that the reaction is exothermic, means delta H is negative. Now the formula for K versus 1 upon T is the ln K is equal to delta H naught upon R minus delta H naught upon upon R into T. If we are drawing ln K versus 1 upon T and delta H naught, he has said that exothermic reaction means it is negative. If this part is negative, then overall if we draw the curve ln K versus 1 upon T, so it will increase in this manner. This curve is correct. This is the intersect which is delta S naught upon R. Now delta S naught upon R, this curve is valid if delta S naught is greater than 0. Now suppose if delta S naught is negative, less than 0, then the curve will be starting from this point and it will go like this. So the A curve is correct, B curve is correct, and remaining 2 curves C and D are for endothermic reactions. So for the exothermic reaction, A and B are the correct option. So the answer is 2. Electrochemistry chapter, which is in 12th class. Electrochemistry chapter. What is saying? How long approximate should water be electrolyzed by passing through 100 ampere current so that the oxygen released can completely burn 27.66 gram diboron. So he is asking for time period approximate, and he is saying that the water is electrolyzed. When water is electrolyzed, it will produce hydrogen gas along with oxygen gas. Second thing, the current passed is 100 ampere. Now he is asking that this oxygen produced should oxidize, completely burn diboron. Diboron means B2S6. So the water is forming oxygen gas, and oxygen is useful in the burning of diboron. So first we write the diboron B2S6 plus its combustion with oxygen. It will form B2O3 plus 3H2O. I am balancing this reaction. 3 plus 3 means oxygen 3. Now B2S6 is given as 27.66 gram, and molar mass of B2S6 is also 27.66 gram. Means number of moles of B2S6 is equal to 1. We want to burn 1 mole of B2S6. Now the required oxygen is equal to 3 mole according to stoichiometry. 1:3 is a stoichiometry. 3 mole of oxygen is required, and which should be produced by electrolysis of water. Now the formula for electrolysis is, first formula is equal to weight, oxygen is equal to equivalent weight of oxygen I into T upon 96500. Or directly we can write mole oxygen is equal to IT upon valency factor or N factor into 96500. Now what is N factor? H2O is being converted into oxygen. Oxygen is 0 oxidation state and water is -2 state. So the change in oxygen per atom in oxidation state is 2, and 2 atoms are there, means valency factor is equal to 4. If I put valency factor 4 in this formula, mole oxygen required is 3, I current is given as 100 ampere, time in second we will get from the formula, valency factor 4 into 96500. So after solving this, we will get time period as 12 into 965 second, and for converting it into hour, 12 into 965 upon 3600, and this is approximately 3.2 hour. So the correct answer is 3.2 hour. 12th class coordination compound chapter. Coordination compound chapter. The question is that this complex is reacting with Br minus ion and the product is formed. So you can see the difference. 2 Br atom are there and 1 ammonia ligand is replaced by the Br. So in this complex reactant side 2 Br is there, 2 Br are there, and in the product side 3 Br are there. The options are, first 2 isomers are produced if the reactant complex is cis isomer, 2 isomers are produced if the reactant complex is a trans isomer, only 1 isomer is produced if the reactant complex ion is a trans isomer, only 1 isomer is produced if the reactant complex is a cis isomer. Okay, and these are the option first, second, third and fourth. So in this complex, first we are looking into reactant side. It has 2 geometrical isomers. So first I am drawing its cis isomer. In the cis isomer Br, and this is ammonia, this is ammonia, and this complex is being reacted with Br minus ion. So what will happen, that this Br minus will replace one of the ammonia from these positions. So there are 2 chances that this ammonia is replaced or this ammonia is replaced. So the 2 compounds will be formed. I am drawing Br, and in the perpendicular direction 1 Br is formed. This is called as facial isomer. If I replace this ammonia from this position, then this is Br, and Br is formed. Now 3Br are into the same plane. This is called as meridional form. So from the cis form, two isomers are formed. Means the first option is correct. Two isomers are produced if the reactant complex is a cis isomer. We have checked the cis isomer. Now we are checking for the trans isomer. Trans means Br, two Br ligand are in opposite direction. Here is ammonia, ammonia, ammonia and ammonia. Now I am replacing one of the ammonia sorry, I am replacing one of the ammonia with the Br atom, Br ligand. If I replace this ammonia, then all Br will be in the same plane, means it is a meridional form. If I replace this from the Br, then if I take this plane, all 3 Br will be in the same plane, like we can watch this plane also. If I replace this ammonia, again 3 Br will be in the same plane. If I replace this ammonia with Br, again 3 Br will be in the same plane. Means in every case 3 Br will be in the same plane, means only one form of meridional is formed. So cis can form two form, facial and meridional. Trans will form only one form, this is meridional. So the third option, only one isomer is produced if the reactant complex is in a trans isomer. So first and third options are correct, means first and third options are in option number 3. So correct answer is 3. Now the next question is from ionic equilibrium, which is in 11th class syllabus. What question is saying? An aqueous solution contains an unknown concentration of Ba+2. And the last part is asking what is original concentration of Ba+2. Suppose in the original solution Ba+2 concentration was x molar and we have to find this concentration. Further is saying when 50 ml of a 1 molar solution of Na2SO4, he is taking Na2SO4 as 50 ml and the concentration is 1 molar, is added into BaSO4, BaSO4 just began to precipitate. Yani this is added into Ba+2 solution and this will give precipitation of BaSO4. ठीक? He has told that just begin to precipitate, means ionic product Q must be equal to Ksp. Ksp means solubility product, and this is equal to Ba+2 into SO4 minus 2. Ksp is given as, in this question, the Ksp is equal to 1 into 10 to the power minus 10. Yes. So the Ksp given of the BaSO4 is 10 to the power minus 10. We have to solve Ba+2. We have to find the Ba+2. Now what we are doing, that the concentration of this Ba+2 is x molar, and when 50 ml is added, BaSO4 just began to precipitate and final volume is 500 ml. So when final solution is having 500 ml volume, means Ba+2 added was 450 ml. What we are doing? We are adding Ba+2 into Na2SO4. Na2SO4 is a 50 ml and Ba+2 is 450 ml, so that the final volume becomes 500 ml. Now from the molarity concept, when we are adding into this solution, its molarity could be taken as M1V1 is equal to M2V2. This is 50 ml, molarity 1, and final solution is 500 ml, molarity we have to find. So the final molarity of Na2SO4 is 0.1. Why it is a final molarity? 50 ml is added and the final solution is 500 ml. So it is diluted 10 times, means the concentration will reduce to 1/10 times. So if Na2SO4 concentration is 0.1, it will dissociate and give SO4 minus 2 as 0.1 because salts are 100% ionized. What we will do? We will put this concentration into this formula. Now Ba plus 2 was originally x molar and the volume added was 450 ml. But after mixing, the final concentration is 500 ml. Again we are putting this formula for Ba plus 2. Ba plus 2, for Ba plus 2 M1 V1 is equal to M2 V2 after dilution. M1 is equal to x, volume 450, molarity unknown and final volume is 500. Means final molarity is equal to x into 9/10. This concentration of Ba plus 2 we can put here and the unknown will be x in this formula. So after putting over here, the x will come out as 1.1 into 10 to the power minus 9 molar. Means correct answer is 4 for Ba plus 2 original concentration. We can understand it again. Ba plus 2 originally x molar, 550 ml was added so that the final volume becomes 500 ml. These two solutions are diluted. It is being 50 ml to 500 ml, it is being 450 ml to 500 ml. So we are putting M1 V1 formula dilution के लिए. So the final molarity of Na2SO4 is 0.1. So sulfate is 0.1. We are putting in KSP expression and Ba plus 2 is 450 to 500 ml. So the final molarity of Ba plus 2 is x into 9/10. After putting over there, x is 1.1 into 10 to the power minus 9. 73 is from chemical kinetics chapter. Chemical kinetics chapter, which is in 12th class. Now what is saying? That the rate of decomposition. So the R1 is equal to 1 torr per second and next R2 is equal to 0.5 torr per second. And the initial pressure was P was 363 torr. Now we know that the rate is proportional to concentration which is raised to power n and n is order. In this question he is asking about the order of reaction. So what is saying, the rate of decomposition of the sample of gaseous acetaldehyde initially pressure 360 torr was 1 torr per second when 5% has reacted and 0.5 torr per second when 33% had reacted. The order of reaction is. Now this rate is when it is reacted as 5%. Means, or we can write the rate is also proportional to pressure and which is raised to power n, n is order. So we can say that R1 upon R2 must be equal to P1 upon P2 and which is raised power n. We have to find the order n. Now what is the value of P1? P1 means this is rate when 5% reacted and this is rate when 33% is reacted. Means this was initial pressure and 5% has been reacted, means 95% of this is remaining. Means P1 must be equal to 0.95 times of P, where P is 363 torr. Understand this thing? Initial pressure was 363 and 5% has been reacted. Means it is consumed. Then the remaining amount will be, in terms of pressure, will be 95% of P. This is rate when 33% has been reacted. Means P2 will be equal to, remaining will be 66%, yani ki 0.66% of P. If I put these two in this formula, then 1 upon 0.5 is equal to 0.95 P upon 0.66 P. The ratio is equal to 2, and this ratio will be approx 1.44 and power n. 1.44 I can write as root 2 power n, means 2 power n by 2 is equal to 2, means n by 2 is equal to 1, so the order n is equal to 2. So the correct answer is 2 and the order of reaction is 2. Next question 74 is from thermochemistry topic. Thermochemistry topic, which is in class 11th. What is saying? The combustion of benzene gives CO2 and H2O. Given the heat of combustion of benzene at constant volume is minus 3263.9 kilojoule per mole at 25 degrees centigrade. Find heat of combustion in kilojoule per mole of benzene at constant pressure. So he has given heat of combustion delta Hc of benzene at constant volume. Now I should write it, heat of combustion at constant volume we can write as delta E, change in internal energy. So he has given delta E as minus 3263.9 kilojoule per mole at constant volume. What is asking? He is asking heat at constant pressure. Heat at constant pressure is called as delta H enthalpy change. So we have to find delta H enthalpy change. So delta H is equal to delta E plus delta Ng RT. This formula is valid for chemical reaction. We can say that this question is based on bomb calorimeter, and in the bomb calorimeter combustion takes place at constant volume, and by the basis of constant volume the heat is called as delta E change in internal energy, and we are finding delta H enthalpy change, which is a heat at constant pressure. So we have to find delta H. Delta is given as minus 3263.9 into 1000 joule. I am converting into joule. The value of R gas constant is 8.314 joule per mole Kelvin. The temperature is given as 25 degrees centigrade, means 298 Kelvin. Now we have to find delta Ng value. So for delta Ng value we have to write the complete reaction. Benzene is being combusted with oxygen. Oxygen is gas and it is forming CO2 gas plus H2O liquid. If I balance this reaction, 6 carbon are there. Before CO2 6 coefficient is there, hydrogen 6, 3 coefficient before water, and if I balance oxygen 12 plus 3 15, so it is 15 by 2. So delta Ng will be 6 minus 15 by 2 is equal to minus 3 by 2, and this delta Ng value we have to put in this formula, and after solving this we will get the answer in joule, which is again converted into kilojoule because he is asking in kilojoule per mole, and the answer will be first minus 327.6. These two answer cannot, because delta H is, this sign is negative and this sign is also negative, so the value will be larger. Then we can put the common sense, there is no need to solve the problem. This is basically negative, this is negative, so the value will be larger in negative than the given as 3263.9. So the answer is slightly larger than 3263.9, it is 3267.6. Question is from mole concept, class 11th. The ratio of mass percent of carbon and hydrogen of an organic compound CXHYOZ is 6:1. If one molecule of above compound contains half of as much oxygen as required to burn one molecule of compound CXHY completely to CO2 and H2O, the empirical formula is. So the first thing is that in CXHYOZ, if I analyze this thing, then the X atom of carbon plus Y atom of hydrogens are there. X atom carbon means 12 Mu, 12 X Mu, and Y atom hydrogen means Y into 1 Mu. What is saying? That the mass ratio is of carbon and hydrogen 12 by X is to Y is equal to 6 is to 1. If I solve this problem, then X by Y is equal to 1 by 2, means Y is equal to 2X. So the formula is CXH2XOZ. If I see one molecule of this, it contains oxygen atoms, the number is equal to Z in this compound. Now he is saying that the one molecule of compound CXHY is completely combusted. CXHY means CXH2X is combusted with oxygen and XCO2 plus XH2O is formed. So the oxygen, after balancing this, the oxygen atoms molecule will be 3x by 2. So for the one molecule of CXHY, the required oxygen molecules are 3x by 2 molecules. 3x by 2 molecules of O2 required. Means atoms are 3x atoms of oxygen are required. Now what is saying? That the one molecule of this compound contains half of much oxygen as required to burn one molecule of compound CXHY. Means this Z is equal to half of the 3x by 2. So we are having formula CXH2XO 3x by 2. If I solve for empirical formula, then the ratio is x is to 2x is to 3x by 2, and this will be 2 is to 4 is to 3. So the correct formula is C2H4O3, and C2H4O3 is the first option in this question. Number 77 is from chemical bonding, inorganic topic, in from 11th class syllabus. He is asking which of the following are Lewis acids. So we define Lewis acid which can accept electron. And which can accept electron, there are the categories are, first category which are electron deficient compound. What is meant by electron deficient compound? Ki their octet is incomplete, or vacant d orbital, the compound having vacant d orbital, and another one is all cations, could be called as Lewis acid. So in this question, if I see BCl3, the central atom is having 6 electron, means it is electron deficient. So one option is BCl3. If I put LCl3, means aluminum is having 6 electron, this is also electron deficient. pH3 octet is complete, so this is not the option. Now in SiCl4, silicon octet is complete, but the silicon is having vacant orbital, vacant d orbital, so it can form easily SiCl6 minus 2. So since it is accepting electron from this ligand chlorine, it can also act as a Lewis acid. So the correct options are this option, because the pH3 is not correct, This option because of pH3 is not correct. BCl3 is Lewis acid, AlCl3 Lewis acid, SiCl for Lewis acid. So the answer must be 1 and 3. So in the single type question, so JEE has to give two answers for this question, 1, 3 or both. When metal M is treated with NaOH, a compound X is obtained. When metal M is treated with NaOH, a white gelatinous precipitate is obtained which is soluble in excess of NaOH. The compound X, when heated, strongly gives an oxide which is used in chromatography as an adsorbent. The metal M is. So he is saying that this X is soluble in excess of NaOH. Excess of NaOH. Suppose this hydroxide is formed and it is soluble in NaOH, means it is reacting with NaOH. So this must be amphoteric hydroxide. And out of these four options, amphoteric oxide could be ZnOH2 or AlOH3. Now the two options could be correct, zinc or aluminium. But further he has said that strongly heating, suppose I consider AlOH3, this X. So when it reacts with NaOH, it forms AlOH4 minus, sodium metaaluminate. And when this sodium metaaluminate is strongly heated, it gives Al2O3 oxide. And this is the fact that Al2O3 oxide is used in chromatography. So the answer is aluminium metal. Chemical bonding, and the subtopic is molecular orbital theory, MOT. So he is asking that which of the following molecule is not viable. The molecule which is having bond order less than equal to 0 are not found in, are not stable, means I can say these are not viable options. So how to check the viable options? I am taking first option, H2 minus 2. The option is H2 minus 2. So H2 minus 2 means 2 plus 2 is equal to 4 electron. Now this contains 4 electron. Now what we have to do? We have to fill this 4 electron according to molecular orbital theory. If I put sigma 1s2, then sigma 1s2 star. In the bonding molecular orbital 2 electrons are there. In the ending bonding, in the anti-bonding, the 2 electrons are there. So what is the formula for bond order? Bond order is equal to 1 by 2 Nb minus Na, number of electron in bonding orbital minus number of electron in anti-bonding, and it is coming as 0. 0 means no bond is formed, and when no bond is formed, that the molecule is not stable in nature. So the first option is the answer, H2 minus 2. Also from chemical bonding, structure part, and it is an 11th class topic. What is asking? Which of the following compound contains no covalent bond? So first option, KCl is an ionic compound which has ion K plus and Cl minus. So it has no covalent bond. Second option, PH3. The structure is like that. It means it is having covalent bond. Third option, O2. The structure of O2 is this. Means it is having covalent bond. Diboron B2S6. The structure is like that. HBH. Banana bonding is this. HH. It is also having covalent bond. So the only compound which is not having any covalent bond is KCl. So the answer is fourth, KCl. 83 is from solid state chapter. and the portion is defects in solid. Solid state is 12th class chapter. He is asking which type of defect has the presence of cation in interstitial site. What is interstitial site? That in the arrangement of solid, this vacant space is called as interstitial site. So if a small atom comes into this side, the effect is Frankel defect. So metal deficiency defect means metal are missing from the lattice, it is going from the out from the solid. Schottky defect means both cation and anion are missing from the solid. Vacancy means ion is missing from the site. Frankel means any smaller ion can enter into the vacant places between ions, which is called as interstitial site. And this defect, when cation is coming into interstitial site, could be Frankel defect. It is not necessary that only cation can come into interstitial site. If anion is smaller than cation, then it also enter into interstitial site. But the appropriate answer is Frankel defect.